Hello everyone, welcome to Pre-calc Lesson 1.7, Transforming Inverse Graphs. So before we start the transformation process, let's just review what an inverse graph is. So we've got this equation here, f of x equals 1 over x. We call that an inverse graph. And if you forgot what this looks like, let's just do a quick xy chart. So let me put in 0, 1, 2, and I'm going to plug that in here. Well, 1 over 0 is undefined, so it doesn't exist there. 1 over 1 is 1. 1 over 2 is 1 half. What happens if I put in a 1 half for the x? 1 over 1 half is 2. So you get an idea of what's going to happen here. X equals 0 does not exist. So that's going to be an asymptote. All right, so I've got this 1, 1 coordinate, 2, 1 half. I think you can see the pattern 3, 1/3, so on and so forth. 1 half, comma 2, 1/3, comma 3. And I'm going to have this graph that looks like this. And this is the key point that I'm going to focus on. We're going to list two key points here. That's 1, 1. Now, if you think about it, we also have an asymptote here because the y value can never be 0. 1 over something can never be 0. Now, this is just half the graph because if you think about it, well, what happens if you put in negatives? Well, -1, -2, -1 half, all that's going to happen is these values right here are going to be negative. So we get a very similar graph, but it's reflected through the origin. It's going to kind of look like this. And this coordinate here is going to be -1, -1. So that's our base inverse graph. And what we're going to do is we're going to take this right here and we're going to transform it. We're going to move it up, right, left, down. We might do a stretch that pulls all of these upward. It just depends on what transformation we're given. So let's take a look at a few. Okay, example 2, our first one. What we notice here is that this tells me I'm going to move my graph right 2, and this tells me I'm going to move it down 3. So right 2, I'm going to move those asymptotes, down 3. Now we're just making sketches, all right? We're not going to be using a calculator. This is calculator inactive. And if you take a look up here, I'm only going to require you to identify two key points. It'll be these two right here on opposite ends of the asymptotes. So we don't have a vertical stretch at all. All you have to do is kind of repeat this pattern in relation to those asymptotes. So you just have to bring that down here. Okay, so that's going to look like this. Got one piece that's going to be here, and then one piece that's going to be here. And I'd like you to identify these two coordinates. Okay, you can write them on the graph, you can write them on the side, it doesn't matter. But remember, this is your origin, so you're going from here, 1, 2, 3, -2. So this coordinate right here is 3, -2. And the one down here looks like it's 1, -4. Now, before you move on, especially if this is a quiz or a test, you want to verify you've done this correctly, you're going to check these coordinates into this original function. So what I'm going to do is I'm going to take a 3 and plug it in for the x here. And I better end up with a -2. So if I put a 3 here, I get 3 minus 2, which is 1. 1 over 1 is 1. 1 minus 3 is -2. Well, that checks. Now let's take the 1 here, plug it in. 1 minus 2 is -1. 1 over -1 is -1. -1 minus 3 is -4. And that checks. So I'm pretty confident I did this correctly. Okay, a little bit more challenging on this next one. So now what I have is -2 over x plus 4. Well, I've got two things going on here. That, if you remember, is going to be a reflection in the x or the horizontal. This is a vertical stretch times 2. So it's going to pull it upwards or downwards by a factor of 2. And then this right here is up 4. Okay, so my asymptotes have shifted up 4. And there's no horizontal shift, so this is still a vertical asymptote. Okay, so this is the tricky part, all right? This vertical stretch, basically what it's going to do, and I'm going to scroll back up here, it's going to take this coordinate here and stretch it upward by a factor of 2. Well, that's just a 1, so 1 times 2 is 2, so it's going to move that coordinate here. So it's going to kind of pull this graph upward quicker. Likewise, on the other side, if the scale factor is 2, it's going to pull it downwards by a factor of 2. So it's going to pull this graph downwards quicker. Now, don't forget, there's also reflection in the x. So this piece is going to get reflected over the x-axis to here, and this piece is going to get reflected over the x-axis to here. All right, so let's sketch this in. So normally, I'd see a piece here, but remember it's going to get reflected, so now it's going to be down there, and I've got this vertical stretch. So my key point is going to be pulled downward by a factor of 2. Look like this. And my other piece can get pulled upward by a factor of 2. It's going to look like this. So let's see, just a reminder, there's my origin. So I've got to write the coordinates of this point. It looks like that's 1, 2. And the other point's going to be negative 1, 1, 2, 3, 4, 5, 6, negative 1, 6. So before we move on, let's check it. I'm going to plug a 1 in here. So I've got negative 2 over 1. That's just negative 2. Negative 2 plus 4 equals 2. Yeah, that's what this is. Good. Now let's plug in a negative 1 right here. So negative 2 over negative 1 is positive 2. Positive 2 plus 4 equals 6, and that's what I got there. So you checked it algebraically after you used your transformations and sketched them. Our last couple examples, we had a new twist. First, let's take a look at what we know on this equation here. That is going to be a vertical stretch times 3. That's going to be up 1. That's going to be left 2. So the question is, what does the absolute value do to the function? Well, a quick review of our base inverse function looks like this, right? Well, if you think about what absolute value does, it makes everything positive. So no matter what I plug in for the x here, no matter what value, negative, positive, how large, how small, I'm going to take the absolute value of it. So this value here always ends up being positive. Well, 3 over a positive is always going to be a positive, and I'm going to add 1. So this whole thing is always positive, which means it has to be above the x-axis everywhere. So it's going to take this piece and flip it up here so it looks like that. All right, before we get there, let's sketch in what we know. We've got left 2. And we've got up 1. And we're going to have a vertical stretch of 3. So instead of being right here, that's going to get stretched up by a factor of 3. Okay, so that's going to go right here. And again, I'm just sketching this in. I only need one key point on this piece. And that looks like it's got coordinates negative 1, 4. Now, normally, if I didn't have the absolute value, the other piece of this would go down here. But that absolute value flips it up here because everything's going to be positive now. So if I sketch that in, that's going to look like this. It's a mirror image of the other one in that vertical. The coordinates of that point, negative 3, 4. So I'm not quite as confident with this one as I was on the others, so I definitely want to check this. I'm going to put a negative 1 in for the x right here and see if this whole expression then gives me 4. So negative 1 plus 2 is 1. 3 over 1 is 3. And 3 plus 1 is 4. And that's what I got, so that checked. Now let's plug in a negative 3 right here. So I've got negative 3 plus 2 is negative 1, but then I take the absolute value of that, which is 1. So again, that gives me 3 plus 1 is 4, and that's what I got here. So I know that one checks as well. So it's a great way to check when you're done, assuming all of these are calculator inactive, and you have to be able to sketch these without using your calculator. All right, our last one. So once again, we kind of talked about what the absolute value does. Let's identify everything else we got going on here. That's going to be reflection in the horizontal, or reflection in the x. That's a vertical stretch times 2. That's up 3. And that's left 5. Okay, so what I want to do now is I want to take care of up 3, left 5 by sketching in my asymptotes. Okay, let's do left 5 first. 1, 2, 3, 4, 5. So that's going to be my vertical asymptote. And up 3, 1, 2, 3. There's my horizontal. So now, don't forget, this is where it gets a little confusing. Number 1, I've got a vertical stretch times 2 and a reflection in the x-axis. So this piece here, all right, I've got to do a vertical stretch times 2 and then reflect it in the x-axis. So it's actually going to come down here. All right, vertical stretch of 2, reflected in the x, and I have this. Now, remember what the absolute value does. All right, let me make a quick sketch. If I just sketch y equals 1 over absolute value of x, I get this here. If I were to sketch in y equals negative 1 over absolute value of x, those two basically get reflected in that x-axis. So the absolute value will make both of these pieces on the same side of your horizontal. Okay, if there's a reflection in the x, they'll both be below. If there's not, they'll both be above. So obviously this one does have that reflection. So my other piece I'm going to graph is going to be the mirror image over on this side. So now let's identify those 2 key points. This first one here is negative 1, 2, 3, 4, negative 4, 1. And this one is negative 6, 1. So you always have to identify those. And the last thing I'm going to do is I'm going to check. I'm going to plug a negative 4 in here and see if all of this then gives me a 1. Negative 4 plus 5 is 1. Negative 2 over 1 is negative 2. Negative 2 plus 3 is positive 1. And that's what I got there. That one checks. Now let's plug in a negative 6. Negative 6 plus 5 is negative 1. Absolute value of negative 1 is positive 1. 2 over 1, negative 2 over 1 is negative 2. Plus 3 is positive 1. And that's what that one is. That checks. So now I'm 100% confident I did this correctly, showed all the work, identified the transformations, and made my sketch. Okay, so that wraps it up for day 7. Again, I know I sound like a broken record, but do not hesitate to ask questions, especially as we kind of progress throughout this unit. We're getting closer to the unit test. Bring questions to class, Zoom, email, Brave Square, whatever you prefer, but make sure you get your questions answered. Okay, thanks a lot, guys, and we'll see you soon.